Okay, this is going to be something you haven't seen before. The Central High School Speech Club has 7 members. I'm going to call them Tom, Charlie, Sally, Harry, Louisa, Beth, Don. The club's going to compete in an improv invite where 3 club members are chosen at random. How many ways can 3 members be chosen? Well, you could do it the long way, but this video would be like 2 hours long if I did it, okay? So you go Tom, Charlie, Sally, Tom, Charlie, Harry, Tom, Charlie, Beth, Tom, Charlie, Don, okay? Tom, Charlie, Louisa, Tom, Charlie, Beth, okay? I mean, a bunch of ways. You go Harry, Louisa, Don, okay? Sally, Beth, Harry, okay? That is going to take forever, okay? Essentially what you're going to use is known as the combinations rule. This is how you figure out how many combinations you can pick, okay? You put a C for combinations. You put how many you have to pick from here, and then how many you're going to pick here, and then how many you're not going to pick here. You just take 7 minus 3, so there'd be 4, okay? This is how you evaluate combinations. You put 7 with an exclamation point. That's actually known as a factorial. Okay, that's what that symbol is called. They don't just call it exclamation point, they call it factorial. Then you divide it by the 4 and the 3. Both of those would get factorial. Now you're like, well, how do I do that? What a factorial means, if you have 7 factorial, that means you multiply 7 by all the integers down to 1. 6, 5, 4, 3, 2, 1. Okay? But you see, I'm going to stop at 4 factorial. I'm just going to go 7 times 6 times 5 times 4. Stop with the 4, put a factorial sign on the 4, because this 4 factorial here will cancel this out. So there's no need to number that down because that just cancels out with the denominators 4 factorial. Now we have the issue of the 3 factorial. You need to go 3 times 2 times 1. So now all you do is find the product of 7 times 6 times 5, and that's 210. And then 3 times 2 times 1 is 6. So then 210 divided by 6 is 35. So there would be 35 ways. Okay, there are 10 people chosen in a class. If we choose 4 class members at random, how many ways can the 4 members be chosen? It's the same thing that was going on here. So you're finding the combinations effect. So we write C for combinations. We have 10 to pick from. We are picking 4, so that would leave 6. 10 minus 4 is 6 that we would not pick, okay? So we put the 10 factorial, and then we put the factorial that we are picking. You can put these in any order. Just do the higher one first, okay? As long as they're both down there. Because remember, that means multiplication, and that's commutative. It doesn't matter the order. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now there's no need to go all the way down to 1 when I got a 6 sitting there where I can just stop the countdown of the factoring. Okay? Stop, because the 6 factorials would cancel. But then we have the 4 factorial, and that one needs to be factored down to 4, 3, 2, 1. So then I find the product on the top. 10 times 9 times 8 times 7, and that's 5,040. And then 4 times 3 times, that's 12, that'd be 24. Then I would divide 5,040 by 24, and I got 210 ways to put those into pairing. Again, if you wrote 10 names, you would be there for a long time figuring out all the possible combinations of 4 people, but that's how many. There are 6 people in a class. If we choose 2 people at random, how many ways can the people be chosen? Now 6 would be more doable this way, okay? See, here I'll even show it. I'll draw 6. Tom, Charlie, Bob, Louisa, got to get some females in here, Sally, and something with a different name. Sally, Why is this taking me so long to think of a name? Yolanda, okay? So you put Tom with TC, TB, TL, TS, SY. Now, CB, CL, CS, CY. I don't do TC because I already got that one, okay? I don't do CT. Now, BL, BS, BY, okay? Then LSLY, and then SY. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I should come up with 15 when I do this. If I don't, I did something wrong. Okay, so that's a long way. So 6, 2, and 4. So we factor the 6 down, we would stop the countdown at 4. Then 2 factorials, 2 times 1. So that's 30, and that's 2, and that's 15. That algorithm works every time.